Okay, so this is our first prototype that we're going to try. I finished welding these on. They're still a little bit warm. So let's have a look. Okay, so my design said 10 inches would be this distance, and I have a 4.5 inch top bracket, and the hole is a 1/2 inch hole, 5/8 down, 5/8 in. Let's say I change it to 5/8. The bottom bracket is 3 inches long, and the hole is 5/8 and 5/8, a 1/2 inch hole. This was 3 inches by 3.5, and I don't remember what this was. Let's have a look. By 2 inches. And the bottom one was a 3 by 3.5 inch piece of 1/8 inch that I welded onto that bracket that I cut off. And this is 3/16. So let's see what it does. Okay, so hole to hole should be 16 inches when it's in this orientation. So let's see, with 10 inches of that and our 4.5 and our 3, if my holes line up to be 16. All right. Hole to hole is, I would say, about 16, and my bracket is 9.5. So it's not 10 as I thought. It's 9.5, which still might work. Okay, now we need to make this part go to 20 inches, and that will make hole to hole 26. Let's see if that happens. The power is invested in me by the state of New York. Pretty wobbly. We need some, it wants to lay down, so we'll let it lay down. And we said this had to be 20. Okay, that's 20. My holes should be 26, which, if we look, hole is going to be 26, and that's what we found. So it does seem to fit, and I think you can see here I need this clearance so it doesn't hit this main beam or the bottom of the thing. So that's what the constraints were. So this had to be long enough and offset enough that that will work. So theory only takes you so far, design only takes you so far. Maybe Thursday we're gonna put this thing in and see, and let's see how and one of the issues was stability or rigidity. So that one's good. So it has a little bit of wobble, or play, I guess is the right word. I can't do that with holding the camera, but it has a little bit of play when it's down close. So I had to make this as open as possible, but yet extend enough to 10 inches so to get the travel we needed. There's the ratchet type that we tried, but the reach wasn't long enough. And here is a fixed bar, which it came with. but it requires like a tractor and a come along or a chain hoist to like move the panels to line it up.
You know, we need some washers.
What do you think of that? It says 51, I think. What's it supposed to be? 65?
Let me check.
65.7 to 66.5, so
Yeah.
0.8 degrees at the top end. Going up, wrong way. Coming down. So 5 degrees when we're at 28, and most of it's from that bolt, which needs to have a smaller clearance hole. All right, a quick summary. So first of all, the design was functional. My welds held, which was a good. He was able to use an impact driver to operate the scissors jack to make the panels go up and down, extend and retract. So that was a goal, and it did work. So it was functional. And when it was fully extended all the way up at 15 degrees, there was only 0.8 degrees of play or wobble when I tried to shake it. So it was pretty tight, not a lot of play at full extension. So that was good. Okay, so now for some of the not so good things that I wasn't expecting. So there was like 5 degrees of play at 28 degrees, which isn't even all the way down. We have to go to 65, so this is almost like a lot flatter. And there's a lot of play. Some was because this hole was oversized, so they didn't have the right size drill, but the scissor jack itself has a lot of play in it, so that's may not be functional or might not be operational. Going up didn't seem to be too much of a problem, but coming back down, bringing this from like almost vertical back to horizontal, you can see this is a bigger impact wrench because the small one wasn't working, wasn't doing it. So it's taking a lot of force to bring it back down. When this is retracting, closing up again, this screw, which I think is a 1/2 inch screw, is under compression. It's trying to force these ends apart. So what happens is this starts to bow. So the screw is actually like bowing. And on the ends here, it was grinding all the metal off of the washers with the force it took to try to bring this back down. So there's never really like a failure in engineering, right? I mean, you try your best, your first prototype, and then you see if it works, doesn't work, what you can change. So this was functional. It fit and it worked, went up and down with the drive, but it's too much play and it's too much force. The rod was bending and stuff. So I don't think that's an operational solution. He bought this one and had someone else weld ends on it, and we installed this one. And this one is pretty nice. It goes up and down with the ratchet here. It doesn't have a lot of wobble in it, a lot of play. Only problem is it only has 8 inches of travel. We need 10 to get it to go from, 15 degrees to 65 degrees. So this does not have the long enough travel in it. So I think we're going to look at maybe modifying one or buying one or making one of this variety as the next attempt. So I did a quick little CAD. So this from here to here is 5.5 inches. So I'll have 5.5 and 5.5. So that's 11-inch travel. We needed 10, so I gave it a little extra. So 11-inch travel. It's gonna be like a 1-inch screw. The tube is gonna have to be 16.5 inches long. I said 3 inches. It may not be that big, but so it'll be 33.5 fully extended. And when it's fully retracted, it'll be 22.5 from attachment hole to attachment hole. So that's what is a quick design that I did to see what it would take to get 10. So the minimum I can do is 16. So 20, most is 28. So 22.5 is probably like at this hole. So that would be 22.5. And then when it extends to 33.5, it will probably, it's going to be in that hole. So it looks like that design would fit and work. We just have to check the clearance around those brackets to make sure there's enough clearance.